Good evening and welcome back. Tonight, we're venturing into one of the most controversial territories in archaeology and ancient history. We're exploring the work of Graham Hancock, a British journalist and author whose ideas have sparked fierce debate, captured millions of imaginations, and challenged everything we think we know about human civilization. Get comfortable, settle in, and prepare to question the timeline of history itself. Imagine standing at the edge of a great mystery. Before you stretch not just ancient ruins or forgotten monuments, but an entire civilization that vanished so completely that mainstream science refuses to acknowledge it ever existed. This isn't science fiction. This is the world according to Graham Hancock, and whether you believe him or not, his theories will make you reconsider everything you learned about the distant past. Graham Hancock wasn't always a renegade historian. Born in Edinburgh in 1950, he studied sociology at Durham University before building a respectable career as a journalist for publications like The Economist and The Sunday Times. His early books tackled serious issues: corruption in foreign aid systems, international development, topics firmly rooted in observable reality. But in the early 1990s, Hancock took a turn that would define the rest of his life. He began exploring ancient mysteries, and what he found, or believes he found, has been challenging orthodox archaeology ever since. His 1995 book, Fingerprints of the Gods, became an international bestseller, igniting a cultural phenomenon that continues today. Since then, Hancock has published numerous books, starred in documentaries, and most recently, presented the Netflix series Ancient Apocalypse, which became one of the streaming platform's most watched documentary series, despite, or perhaps because of, the firestorm of academic criticism it generated. But what exactly does Graham Hancock claim? What evidence does he present? And why has his work become so polarizing that archaeologists have called for Netflix to reclassify his documentaries as science fiction? Tonight, we're going to explore these questions with careful attention to both Hancock's arguments and the scientific response to them. At the heart of Hancock's work lies a single, revolutionary proposition that we are a species with amnesia. We have forgotten our true origins. Mainstream archaeology tells us that human civilization began around 5,000 to 6,000 years ago with the Sumerians and ancient Egyptians. Before that, we're taught, humans lived as primitive hunter-gatherers, scraping out survival in small bands, possessing no writing, no complex architecture, no advanced knowledge. Hancock says this story is incomplete at best, and fundamentally wrong at worst. According to Hancock, there existed an advanced civilization during the last ice age, roughly 12,000 to 13,000 years ago. This civilization, he proposes, possessed sophisticated knowledge of astronomy, navigation, mathematics, and architecture. Based on what we see in later monuments and the knowledge systems of early civilizations, Hancock suggests its people mapped the world with precision, understood the movements of the stars across vast timescales, and built monuments that encoded this knowledge for future generations. Then, around 12,800 years ago, catastrophe struck. Hancock proposes that a comet, or more precisely, fragments of a massive comet, bombarded Earth. The impacts, he argues, triggered what scientists call the Younger Dryas, a period of dramatic climate reversal that plunged the planet back into near-glacial conditions after thousands of years of warming. Massive floods swept across continents as ice sheets destabilized. Sea levels rose by hundreds of feet over the following millennia. Megafauna went extinct across multiple continents. And, Hancock contends, this advanced Ice Age civilization was largely destroyed, but not entirely. Hancock believes that survivors of this cataclysm scattered across the globe, seeking refuge among the hunter-gatherer populations that had weathered the catastrophe in various regions. These survivors, these refugees from what he argues was a lost world, carried with them the knowledge of their destroyed civilization. In Hancock's interpretation, they taught the hunter-gatherers agriculture, astronomy, architecture, and spiritual practices. They became, in myth and legend, the gods, the culture heroes, the bringers of civilization. This, Hancock argues, explains the sudden appearance of complex societies in places like Egypt and Sumer. It explains the astronomical sophistication encoded in ancient monuments, It explains the global spread of similar myths about great floods, about gods descending from the heavens or arriving from across the sea, about a time before time when the world was different. It's an audacious theory. It's romantic, compelling, and if true, would rewrite human history. But is there any evidence to support it? Hancock points to several lines of evidence, from geology to archaeology to mythology. He draws on the work of various researchers, some mainstream, some fringe, weaving together what he sees as a coherent picture of a forgotten chapter in human existence. The academic response has been fierce and often dismissive. Archaeologists have called Hancock's work pseudoscience, criticized his methodology, and accused him of cherry-picking evidence while ignoring contrary data. They argue that his theories diminish the achievements of ancient peoples by attributing their accomplishments to some mysterious lost civilization rather than recognizing the ingenuity and capability of our ancestors. Yet Hancock's influence persists. Millions of people around the world find his arguments persuasive, or at least intriguing enough to question the orthodox narrative. His books continue to sell. His documentaries attract massive audiences, and occasionally, new archaeological discoveries seem to align with aspects of his theories, even if the mainstream interpretation differs markedly from his own. Tonight, we're going to examine Graham Hancock's claims with a critical but open mind. We'll explore the evidence he presents, the sites he investigates, and the theories he proposes. We'll also look at how mainstream science responds to these claims and why the debate has become so heated. We'll journey from the megalithic temples of Turkey to the pyramids of Egypt, from the flooded coastlines of the Ice Age to the astronomical alignments of ancient monuments. We'll consider comet impacts and flood myths, ancient maps and lost continents. And through it all, we'll ask the central question: is Graham Hancock revealing forgotten truths about humanity's past? Or is he, as his critics claim, constructing an elaborate fantasy from coincidences and misinterpretations? The story of human civilization might be older, stranger, and more complex than we've been taught. Or it might be exactly what mainstream archaeology tells us. The only way to know is to examine the evidence and decide for yourself. So, let's begin at the beginning, with a world very different from the one we know today. A world locked in ice, and a civilization that Hancock believes thrived in that frozen realm before vanishing beneath the waves of a global catastrophe. To understand Graham Hancock's central theory, we need to travel back in time, far beyond the pyramids of Egypt or the ziggurats of Sumer, back to a period when the Earth looked fundamentally different from the planet we inhabit today. We need to go back to the last ice age, specifically to its final stages between approximately 15,000 and 11,000 years ago. During the Ice Age's peak, around 21,000 years ago, the world was a place of extremes. Massive ice sheets, some over 2 miles thick, covered huge portions of the northern hemisphere. Imagine ice 2 miles deep sitting on top of what is now New York City, Chicago, London, and Stockholm. The weight of this ice was so immense that it actually deformed the Earth's crust, pressing it down into the mantle below. But the ice didn't just sit there passively. It locked up so much of the planet's water that sea levels stood roughly 400 feet lower than they do today. This meant that the map of the world looked dramatically different. What are now shallow seas were dry land. Indonesia and Malaysia formed a single continuous landmass called Sundaland. The British Isles were connected to continental Europe. A land bridge spanned from Siberia to Alaska, and all along the continental shelves, exposed by the lower seas, stretched millions of square miles of habitable terrain. In total, approximately 10 million square miles of land that are now underwater were above sea level during the Ice Age. To put that in perspective, that's an area equivalent to all of Europe and China combined, an entire subcontinent's worth of real estate where people could have lived, built, and thrived. And here's where Hancock's theory begins to take shape. What if, he asks, an advanced civilization arose on some of that now submerged land? What if they built their cities and monuments on coastlines that are now hundreds of feet underwater? If such a civilization existed and was subsequently destroyed, how much evidence would survive? How would we even know to look for it? Mainstream archaeology acknowledges that humans have been anatomically modern for at least 200,000 years, and behaviorally modern for at least 50,000 years. But the conventional story says that for the vast majority of that time, Humans lived in small, mobile bands as hunter-gatherers. Civilization, we're told, only emerged after the Ice Age ended, once agriculture allowed people to settle in one place, generate food surpluses, and develop complex societies. Hancock finds this narrative unsatisfying. He points out that anatomically, modern humans with brains identical to ours lived through tens of thousands of years without apparently developing anything approaching civilization. Then, quite suddenly in archaeological terms, around 10 to 12,000 years ago, complex societies begin appearing in multiple locations around the world. Agriculture develops independently in several regions. Monumental architecture appears. Astronomical knowledge becomes evident. Writing systems emerge. Why the sudden leap? Why, after so many millennia of apparent stasis, does human society transform so rapidly? The mainstream answer involves various factors. Climate change at the end of the Ice Age making agriculture more viable, population pressures, social and cognitive developments. Hancock suggests an alternative explanation. What if the knowledge necessary for civilization didn't have to be invented from scratch in each location? What if it was taught, transmitted by survivors of an earlier, destroyed civilization to the scattered hunter-gatherer populations they encountered? This hypothetical Ice Age civilization, according to Hancock, wasn't some crude early society. It was advanced, perhaps not with our technology of computers and aircraft, but with a different kind of sophistication. Based on what he sees encoded in later monuments, Hancock infers they were master astronomers who understood the precession of the equinoxes, a phenomenon that takes nearly 26,000 years to complete a full cycle. From his analysis of ancient maps, he suggests they were skilled navigators and cartographers who mapped the world with accuracy that wouldn't be matched again until the 18th century. Looking at megalithic sites around the world, he proposes they were accomplished architects who could work with massive stone blocks and encode mathematical and astronomical knowledge into their monuments. Most importantly, Hancock suggests, they possessed what he calls spiritual technology. Through meditation, rituals, and the use of psychoactive plants, they had developed profound insights into consciousness and the nature of reality. They could, he implies, achieve altered states of consciousness that gave them access to knowledge beyond ordinary perception. This last aspect of Hancock's theory has drawn particular criticism from academics. Anthropologist Jeb Card notes that Hancock portrays this Ice Age civilization as having psychic abilities and communicating with powerful non-physical beings through psychedelic use. Hancock has indeed been explicit about this, arguing that ayahuasca and other plant medicines played a role in the development of human consciousness and ancient knowledge systems. But let's stay focused on the more testable aspects of the theory. If an advanced civilization existed during the Ice Age, what happened to it? Why isn't there abundant, undeniable evidence? Why are archaeologists skeptical? Hancock's answer brings us to one of the most dramatic proposals in his work, the idea that this civilization was destroyed by a cosmic catastrophe around 12,800 years ago. This catastrophe, he argues, was so devastating that it erased most evidence of the civilization's existence. It triggered climate chaos, caused massive flooding as ice melted, and plunged the survivors into a desperate struggle for survival. The evidence for this catastrophe, Hancock maintains, comes from the geological record, from the sudden climate shift called the Younger Dryas, from the extinction of megafauna across multiple continents, from widespread evidence of fires and flooding. And increasingly, he points to a controversial but growing body of scientific research, suggesting that the Younger Dryas was triggered by comet impacts. This brings us to one of the most important and contentious aspects of Hancock's work, his embrace of the Younger Dryas impact hypothesis. This theory, proposed by a team of scientists in 2007, suggests that fragments from a disintegrating comet struck Earth around 12,800 years ago. These impacts, the theory proposes, caused massive wildfires, triggered rapid climate cooling by injecting debris into the atmosphere, contributed to the extinction of Ice Age megafauna, and may have ended the Clovis culture in North America. When this theory first appeared in scientific literature, it was highly controversial, and many geologists and archaeologists strongly disputed it. But over the past decade and a half, something interesting has happened. More evidence has accumulated. Studies have found impact markers, nanodiamonds, platinum anomalies, and other signatures consistent with cosmic impacts at the Younger Dryas boundary layer in sediments around the world. Not all scientists are convinced. The Younger Dryas impact hypothesis remains debated in academic circles, with critics pointing to issues with reproducibility of results and alternative explanations for some of the evidence. But the hypothesis has gained more traction than many expected, and some previously skeptical scientists have revised their positions after examining the data. For Hancock, this growing body of evidence for a Younger Dryas catastrophe is crucial. It provides a plausible mechanism for the destruction of his proposed Ice Age civilization. A comet bombardment would have been devastating. The impacts themselves would have released enormous energy. The resulting fires would have swept across continents. The disruption to climate would have been severe and sudden. And most importantly for Hancock's theory, the rapid melting of ice sheets would have caused catastrophic flooding. Imagine the scenario: ice sheets 2 miles thick covering North America and Europe. Then suddenly, intense heat from comet impacts and their aftermath. The ice begins to melt, not gradually over centuries, but rapidly. Massive lakes of meltwater form on top of the ice sheets. When the ice dams holding back these lakes fail, unimaginable volumes of water roar down off the ice, carrying everything before them. Boulders the size of houses, chunks of ice like small mountains, racing across the landscape at speeds up to hundreds of miles per hour. When this water reaches the oceans, sea levels rise dramatically, not over centuries but over years or even months. Coastlines that have been home to human settlements for generations are swallowed by the sea. People flee inland if they can. Entire populations are displaced. Knowledge is lost. Continuity is broken. This, Hancock argues, is what happened to his proposed Ice Age civilization. Their cities and monuments, if they built them on what were then coastlines, would now lie hundreds of feet underwater. Based on his interpretation of the catastrophe's severity, their population would have been decimated. Only a few survived, he suggests, scattered to distant regions where, in his reading of global mythology, they became the mysterious civilizing heroes mentioned in countless myths and legends. It's a dramatic scenario, and critics point out that it requires accepting several propositions that mainstream science disputes. First, that an advanced civilization existed during the Ice Age, for which there is no widely accepted archaeological evidence. Second, that the Younger Dryas was caused by comet impacts, which remains controversial. And third, that the survivors of this civilization then spread their knowledge around the world, for which again there is debate about the evidence. Skeptics like Michael Shermer have asked pointed questions. If this civilization was so advanced, where are the tools, the trash, the artifacts? Where are the remnants of their technology? Why hasn't a single city or major settlement site been positively identified? If they had writing, where are the texts? If they worked with metals, where are the metal objects? Hancock's response points to the catastrophic nature of the destruction and the submergence of coastal areas where evidence would have been concentrated. He also notes that absence of evidence is not necessarily evidence of absence, particularly when we're talking about a period when vast areas of habitable land are now underwater and have never been systematically searched by archaeologists. And here we arrive at a crucial point about Hancock's method and why it generates such controversy. Mainstream archaeology builds its understanding through the accumulation of physical evidence, artifacts, structures, dated materials. When archaeologists see a sudden appearance of sophisticated architecture or astronomical knowledge in the archaeological record, they look for precursors, for the gradual development of these capabilities within that culture. Hancock's approach is different. He starts with anomalies, with things that seem out of place or ahead of their time, and proposes that these anomalies can be better explained by knowledge transfer from an earlier, lost civilization than by gradual development. He connects dots across vast distances and time periods, looking for patterns that suggest a common source. This method can produce fascinating insights and thought-provoking questions, but it also leads to what critics call cherry-picking, selecting evidence that fits the theory while ignoring evidence that contradicts it. It leads to arguments from ignorance, the idea that because we can't explain something within the current paradigm, alternative explanations must be true. Yet there's something undeniably compelling about Hancock's work. He asks uncomfortable questions. He points to genuine mysteries that mainstream archaeology hasn't fully resolved, and he does so in a way that captures people's imaginations, making ancient history feel urgent and relevant. So who were these people, this lost Ice Age civilization? Hancock doesn't claim to have all the answers, but he offers suggestions based on his interpretation of ancient myths and monuments. He draws connections between his lost civilization and Plato's Atlantis, though not necessarily located in the Atlantic Ocean as Plato described. Rather, Hancock views Atlantis as potentially being a memory of a real, destroyed civilization whose story was passed down through generations and transformed until it reached Greek philosophers in a mythologized form. He sees what he interprets as echoes of this civilization in the ancient Egyptian concept of Zep Tepi, the first time, a golden age when, according to Egyptian tradition, gods walked the earth and established the foundations of civilization. He finds what he considers parallels in Sumerian myths of the Apkallu, wise beings who, legend says, brought knowledge to humanity after a great flood. Based on textual analysis, he traces similar themes through Hindu texts, describing previous world ages, and through Mayan accounts about the destruction and renewal of civilizations. Are these myths evidence of real events, or are they imaginative stories that different cultures created to explain natural phenomena and give meaning to their origins? That question lies at the heart of the debate over Hancock's work. What we can say with certainty is that the world at the end of the Ice Age was in tremendous flux. Climate was changing rapidly, sea levels were rising, entire ecosystems were transforming, human populations were on the move. It was a time of crisis and adaptation. Whether it was also a time when knowledge from a destroyed civilization spread across the world, teaching hunter-gatherers the foundations of what would become Sumerian, Egyptian, and other early civilizations, remains one of the most intriguing and controversial questions in alternative archaeology. To evaluate this question properly, we need to look at specific evidence. We need to examine the sites Hancock investigates, the monuments he analyzes, the scientific data he cites, and we need to do so with both an open mind and a critical eye, always asking, does this evidence truly support the conclusions being drawn from it? The story Graham Hancock tells turns on a single cataclysmic event that occurred roughly 12,800 years ago. This event, he argues, didn't just change the climate or cause localized disasters. It nearly ended human civilization before it truly began, and it erased almost all trace of an advanced society that had flourished during the Ice Age. To understand why this event is so central to Hancock's theory, and to evaluate whether the scientific evidence supports his interpretation, we need to examine what happened at the end of the last Ice Age in considerable detail. For approximately 10,000 years before the Younger Dryas began, Earth had been warming. The great ice sheets that had covered much of the northern hemisphere were gradually retreating. Glacial lakes formed from the meltwater. Plants and animals were colonizing newly exposed land. Sea levels were rising as the locked-up water returned to the oceans. The planet was transitioning from an ice age to warmer, more hospitable conditions. Then, suddenly, around 12,800 years ago, this warming trend reversed dramatically. Within the span of perhaps a few decades, maybe even less, temperatures plummeted. In Greenland, ice core data shows temperature drops of up to 15 degrees Celsius. The glaciers that had been retreating began advancing again. The warming that had seemed unstoppable came to a halt. This period of renewed cold and dry conditions lasted for approximately 1,200 years. Geologists call it the Younger Dryas, named after a hardy Arctic flower that proliferated during this time. Then, just as suddenly as it began, the Younger Dryas ended. Temperatures shot back up, even faster than they had dropped. Within 50 years, maybe less, Earth had warmed to something approaching modern conditions. The Younger Dryas is not controversial. The evidence for it is clear in ice cores, lake sediments, pollen records, and other geological markers around the world. What has been intensely debated is what caused it. For decades, the prevailing explanation has been that massive influxes of fresh water from melting glaciers disrupted ocean circulation patterns, particularly the Atlantic meridional overturning circulation, which includes the Gulf Stream. When cold fresh water from melting ice sheets poured into the North Atlantic, this theory suggests, it altered the density-driven circulation that carries warm water from the tropics to the North Atlantic. With this heat transport disrupted, temperatures in the northern hemisphere dropped sharply, This explanation is well supported by oceanographic evidence and climate modeling. But in 2007, a multidisciplinary team of scientists proposed an alternative or additional cause. They suggested that fragments of a disintegrating comet struck Earth at the onset of the Younger Dryas, triggering the climate reversal through a combination of impact effects, wildfires, and disruption of ice sheets. This is the Younger Dryas impact hypothesis, and it's become a cornerstone of Graham Hancock's work because it provides a mechanism for the catastrophic destruction he believes befell his Ice Age civilization. The team that proposed this hypothesis, which eventually formed into the Comet Research Group, presented evidence that included elevated concentrations of several impact markers at the Younger Dryas boundary layer in sediments across North America and beyond. These markers included nanodiamonds, which can form under the extreme pressures of cosmic impacts, magnetic spherules, platinum anomalies, and a widespread charcoal layer suggesting massive wildfires. The initial papers drew significant attention and sparked intense debate. Many geologists and archaeologists were skeptical. They questioned whether the markers were truly impact-related, whether they were found consistently at the right layer, and whether the dating was accurate. Some studies failed to replicate the findings. Critics argued that the impact hypothesis was unnecessary, that the conventional explanation involving ocean circulation disruption was sufficient. Over the years since 2007, the hypothesis has weathered criticism, been revised, and accumulated additional evidence. Recent studies have found impact markers in deep ocean sediment cores from Baffin Bay near Greenland, containing high levels of platinum and other elements consistent with extraterrestrial material. A crater-like depression in Louisiana has been identified as potentially resulting from a Younger Dryas impact. Research published in peer-reviewed journals continues to find signatures consistent with the hypothesis. Notably, some scientists who were initially skeptical have reconsidered their positions. Marc Defont, a volcanologist who criticized the hypothesis, later wrote that he had been convinced by new evidence that comet airbursts did occur at the Younger Dryas boundary. Michael Shermer, editor of Skeptic magazine, publicly apologized to Graham Hancock and acknowledged that the evidence for the Younger Dryas impact had become compelling enough to adjust his priors. However, it's crucial to note that the Younger Dryas impact hypothesis remains controversial in the scientific community. Many geologists continue to dispute it. A comprehensive review published in 2023 criticized the hypothesis on multiple grounds, arguing that many of the claimed markers could have alternative explanations, that the evidence hasn't been consistently reproduced, and that the conventional explanation remains more parsimonious. Where does this leave us in evaluating Hancock's use of the impact hypothesis? We can say several things. First, the hypothesis is not fringe pseudoscience. It's a genuine scientific proposition that has been published in peer-reviewed journals and seriously debated in the scientific community, even if it remains disputed. Second, there is growing evidence for some kind of extraterrestrial impact or airburst event around the Younger Dryas boundary, though the scale and effects remain debated. Third, whether this event was catastrophic enough to destroy an advanced civilization, as Hancock contends, is a separate question from whether the impacts occurred at all. Critics point out that even if the impact hypothesis is correct, it doesn't prove that an advanced Ice Age civilization existed. The impacts could have devastated hunter-gatherer populations and megafauna without there needing to be a lost advanced society. The extinction of mammoths, giant ground sloths, and saber-toothed cats. The disruption of the Clovis culture in North America. These can be explained by the impacts and climate change without invoking Atlantis. Hancock would counter that the impacts provide the mechanism for the destruction and the removal of evidence. If his civilization's major population centers were on coastlines that are now underwater, and if those coastlines were hit by massive flooding in the aftermath of impacts that destabilized ice sheets, then the lack of obvious archaeological evidence becomes less problematic. The debate over the Younger Dryas impact hypothesis highlights a broader tension in how we evaluate Hancock's work. When he cites scientific research, even controversial research, he's operating within the bounds of rational inquiry. Scientists propose hypotheses, gather evidence, debate interpretations. That's how science works. The problem arises when he takes these scientific findings and weaves them into a larger narrative that includes elements, like the advanced Ice Age civilization itself, for which the evidence is much thinner. It's worth considering what a genuine Younger Dryas catastrophe would have meant for human populations, regardless of their level of cultural development. The impacts themselves would have been terrifying. Fragments of a comet, potentially kilometers across, exploding in the atmosphere or striking the Earth, would have released energy equivalent to thousands of nuclear weapons. The blast waves would have leveled forests. The heat would have ignited wildfires across entire continents. Following the impacts, the atmosphere would have filled with smoke and dust, blocking sunlight and causing temperatures to plummet. The impacts on the ice sheets would have sent massive quantities of meltwater flooding across the landscape. Tsunami-like waves of water carrying ice and debris would have scoured valleys and drowned settlements near rivers. Then, as the dust settled and the Younger Dryas cold period set in, surviving humans would have faced a return to harsh, near-glacial conditions. Food sources would have become scarce. Migration routes would have changed. Population sizes would have crashed. This is all consistent with what we see in the geological and archaeological record. The Clovis culture in North America does disappear at this time. Megafauna extinction events do cluster around this period. There is evidence of widespread fires. Human populations in many regions do appear to have undergone severe bottlenecks. What isn't clear is whether there was an advanced civilization caught in this catastrophe. Hancock points to global flood myths as evidence that the memory of these events was passed down through oral tradition. He notes that virtually every ancient culture has stories of a great deluge that destroyed the world, and survivors who preserved knowledge through the disaster. The flood myths are real. From the Epic of Gilgamesh to the biblical story of Noah, from Greek myths of Deucalion to Hindu accounts of Manu, from Maya traditions to Aboriginal Australian Dreamtime stories, the motif of a world-destroying flood appears again and again. Mainstream scholars typically interpret these as exaggerated memories of local floods or as symbolic stories. Hancock sees them as genuine historical memories of the Younger Dryas catastrophe. The truth likely lies somewhere in the middle. The end of the Ice Age did involve massive flooding as ice sheets melted and sea levels rose. Coastlines that had been inhabited for generations were submerged. River valleys were inundated. For people living through these events, it would indeed have seemed like the world was being destroyed by water. Their oral traditions would naturally preserve these memories, which would be passed down, embellished, and mythologized over the generations. Consider the scale of what happened. During the Ice Age, sea levels stood approximately 400 feet lower than today. This meant that vast areas of the continental shelves, the shallow underwater areas extending from today's coastlines, were dry land. The Persian Gulf, for instance, was almost entirely dry, with the Tigris and Euphrates rivers flowing through what is now seabed, before emptying into a much smaller gulf. The English Channel was dry land connecting Britain to Europe. Indonesia, Malaysia, and much of Southeast Asia formed a continuous landmass called Sunderland, roughly the size of India. These exposed coastal plains would have been prime real estate for human settlement. They were flat, fertile, close to both marine and terrestrial food sources. If we want to find evidence of Ice Age human occupation, these are exactly the areas we should be looking. But they're now underwater, covered by hundreds of feet of ocean. Any settlements, monuments, or artifacts from that period would be on the seabed, in areas that have never been systematically surveyed by archaeologists. The flooding of these areas wasn't always gradual. Yes, over the full post-Ice Age period, sea levels rose steadily as ice melted. But there were also catastrophic events. Glacial lakes formed on top of ice sheets as surface melting occurred. These lakes could contain volumes of water equivalent to all the Great Lakes combined. When the ice dams containing them failed, the result was megafloods of almost unimaginable scale. The channeled scablands in Washington state preserve evidence of one such flood. Geologist J. Harlan Bretz spent decades arguing that the bizarre landscape there, with its huge channels carved through solid rock, its giant ripple marks, its enormous gravel bars, could only be explained by catastrophic flooding on a scale never witnessed in recorded history. He was ridiculed and dismissed by his colleagues for years. Eventually, the evidence became overwhelming. The scablands were indeed carved by gigantic floods when glacial Lake Missoula's ice dam failed, releasing water that traveled at speeds up to 80 miles per hour, carrying boulders the size of houses, scouring everything before it. And this happened not once but repeatedly. The ice dam would reform, the lake would refill, then fail again. The geological record shows evidence of at least 40 such floods. Each one would have been an apocalyptic event for anyone in its path, and Lake Missoula was just one of many such glacial lakes. Similar catastrophic draining events occurred in other regions where ice sheets were melting. When these massive volumes of fresh water poured into the oceans, sea levels would have risen rapidly, not gradually over generations, but noticeably within human lifetimes, perhaps even within months or years. Coastal settlements would have been inundated. People would have been forced to flee inland, abandoning their homes, their monuments, their accumulated possessions. For survivors, the memory would be seared into cultural consciousness, passed down through oral tradition as stories of the world being destroyed by flood. This geological reality provides a mechanism for the widespread flood myths without requiring Hancock's lost civilization. But it also provides a mechanism that could support his theory. If an advanced Ice Age civilization did exist, and if its major population centers were on the now submerged coastal plains as Hancock suggests, then these catastrophic flooding events would have been devastating to it. The civilization might indeed have been largely destroyed, with only scattered survivors carrying forward fragments of knowledge. Whether these flood myths also preserve memories of an advanced civilization destroyed by the floods is the key question. Hancock believes they do, that the gods and heroes of mythology, the ones who brought civilization to humanity after the flood, were real people, survivors of his Ice Age civilization. Mainstream scholars see these figures as mythological constructs, not historical persons. The Younger Dryas catastrophe, whether caused by comet impacts or ocean circulation disruption or some combination of factors, represents a genuine crisis point in human prehistory. It was a time when climate change was rapid and severe, when megafauna went extinct, when human populations were disrupted. It shaped the world we inherited. Graham Hancock has brought attention to this period and its potential importance in understanding human history. Whether his specific interpretation, that it destroyed an advanced Ice Age civilization, is correct remains hotly debated, but the catastrophe itself was real, and its effects on humanity were profound. As we continue exploring Hancock's evidence, we'll need to keep asking, do the monuments and sites he examines truly suggest knowledge from a lost civilization, or can they be explained by the ingenuity of the hunter-gatherers and early civilizations that we know existed? That question takes us to some of the most enigmatic archaeological sites on Earth, beginning with a place in Turkey that has revolutionized our understanding of prehistoric capabilities, Göbekli Tepe. If you want to understand why Graham Hancock's theories have gained traction despite fierce academic opposition, you need to visit a windswept hilltop in southeastern Turkey. There, among the rolling plains near the ancient city of Şanlıurfa, stands a site that has shaken the foundations of archaeological orthodoxy, a place called Göbekli Tepe. Göbekli Tepe means potbelly hill in Turkish, an unassuming name for one of the most significant archaeological discoveries of the past century. When excavations began in the 1992 under the direction of German archaeologist Klaus Schmidt, what emerged from beneath the artificial mound challenged fundamental assumptions about the capabilities of prehistoric humans. The site consists of a series of massive stone enclosures built in roughly circular or oval arrangements. Within these enclosures stand enormous T-shaped stone pillars, some of them 20 feet tall and weighing 15 tons or more. These aren't rough, crude stones. They're carefully carved, shaped, and decorated with bas-reliefs of animals, scorpions, snakes, foxes, wild boar, predatory birds, abstract symbols that may represent astronomical or spiritual concepts. The pillars are arranged in rings, with two larger central pillars surrounded by smaller ones, the whole structure forming what appears to be a ceremonial or religious complex. The craftsmanship is sophisticated. The engineering required to quarry, transport, and erect these massive stones is impressive. The artistic skill evident in the carvings is remarkable. All of this would be interesting but not necessarily revolutionary, except for one fact. The site dates to approximately 9,600 BC at its youngest levels, and 9,500 BC or earlier at its oldest. That puts Göbekli Tepe's construction at roughly 11,000 to 12,000 years ago. To put that in perspective, Göbekli Tepe predates Stonehenge by about 6,000 years. It predates the Egyptian pyramids by about 7,000 years. It was built when, according to traditional archaeological timelines, humans were still living as hunter-gatherers, with no agriculture, no domesticated animals, no pottery, no metal tools, no cities. And yet here are these megalithic structures, precisely carved and deliberately arranged, requiring coordinated labor from significant numbers of people, demonstrating knowledge of architecture and engineering, clearly serving some sophisticated ceremonial or religious purpose. When Klaus Schmidt first published his findings, he called Göbekli Tepe the world's first temple. It represented, he believed, a revolution in human society, the first time people had come together not to live. There's no evidence anyone resided at Göbekli Tepe permanently, but to worship, to participate in rituals, to create something sacred. The mainstream interpretation, accepted by most archaeologists, is that Göbekli Tepe represents an unexpected sophistication among hunter-gatherer populations. It shows that our ancestors were capable of far more than we previously credited them. It suggests that complex symbolic thought, organized religion, and monumental architecture preceded agriculture rather than following from it. In fact, some archaeologists now suggest that the regular gatherings at sites like Göbekli Tepe may have led to the development of agriculture as people experimented with cultivating the wild grains that grew in the surrounding area. This interpretation maintains that hunter-gatherers, while mobile and non-agricultural, were far from primitive. They had rich cultural lives, sophisticated beliefs, considerable engineering skills, and the organizational capacity to coordinate large-scale construction projects. Göbekli Tepe thus expands our understanding of hunter-gatherer capabilities without requiring us to invoke a lost advanced civilization. Graham Hancock sees it differently. For him, Göbekli Tepe is evidence that supports his theory of knowledge transfer from an Ice Age civilization. The sophistication of the site, appearing seemingly out of nowhere in the archaeological record without clear precursors, suggests to him that the knowledge required didn't develop locally but was brought from elsewhere. In his Netflix series Ancient Apocalypse, Hancock visits Göbekli Tepe and questions whether simple hunter-gatherers could have built such a complex. He points to the massive stones, the intricate carvings, the astronomical alignments that some researchers claim to detect in the structure. He notes that Göbekli Tepe's construction dates to right around the end of the Younger Dryas, the catastrophic period he believes destroyed his Ice Age civilization. His implication is clear. What if Göbekli Tepe wasn't built by hunter-gatherers developing these skills independently? What if it was built by, or under the direction of, survivors from the destroyed Ice Age civilization? What if it represents an attempt by those survivors to preserve or transmit knowledge to the hunter-gatherer populations among whom they had taken refuge? This interpretation has drawn sharp criticism from archaeologists. Professor Necmi Carroll, who leads excavations at the related site of Karahan Tepe, has complained that his interviews for Hancock's show were edited in misleading ways. Other archaeologists working at Göbekli Tepe have distanced themselves from Hancock's interpretations. Critics make several points. First, while Göbekli Tepe is impressively early, it's not without precedent. Other sites in the region show increasing architectural sophistication in the millennia before Göbekli Tepe. There are precursors, even if they're less dramatic. The site didn't appear from nowhere. Second, the assumption that hunter-gatherers couldn't have built Göbekli Tepe is what some scholars call the bigotry of low expectations. Why assume our ancestors lacked the intelligence, creativity, or organizational ability to achieve this? Why diminish their accomplishments by attributing them to some mysterious lost civilization? Third, the site lacks many markers of advanced civilization. There's no writing, no evidence of metallurgy, no domesticated animals, no pottery in the earliest layers. If this was built by or influenced by an advanced civilization, where are those other technological markers? Hancock would respond that his proposed civilization might have had different technological priorities than ours. They weren't building skyscrapers or smartphones. Their advancement was in areas like astronomy, spiritual practices, stoneworking, and perhaps in areas that don't preserve well archaeologically. He also points out that Göbekli Tepe is just one of many similar sites being discovered in the region. Karahan Tepe, still being excavated, has megalithic pillared structures similar to Göbekli Tepe. Other sites like Bonkuklu Tarla and Saburs show similar architectural features. These sites date to roughly the same period and are concentrated in southeastern Turkey, suggesting this was a center of something significant happening around 11,000 to 12,000 years ago. What's particularly interesting is how close this region is to what ancient traditions place as the Garden of Eden. The biblical account places Eden at the source of 4 rivers. 3 of them, the Euphrates, Tigris, and possibly the Aras, rise in eastern Anatolia, not far from Göbekli Tepe. Hancock and other researchers see this as more than coincidence, perhaps a distant memory of this region being the birthplace of civilization after the Younger Dryas catastrophe. There's also the question of what's carved on Göbekli Tepe's pillars. Some of the imagery appears to show astronomical phenomena. One pillar, known as the Vulture Stone, has been interpreted by some researchers as depicting a specific astronomical configuration that could date to around 10,950 BC, right at the onset of the Younger Dryas. Martin Sweatman and Dimitrios Tsikritsis published a paper in 2017 suggesting that carvings at Göbekli Tepe might represent a cosmic impact, possibly the Younger Dryas impact that Hancock emphasizes. They interpreted the animal figures as constellations and the headless man on one pillar as representing catastrophic events. Mainstream archaeologists have largely dismissed this interpretation as speculative, but it has added fuel to the debate. The fundamental question is this: does Göbekli Tepe represent the independent achievement of hunter-gatherers rising to new levels of sophistication, or does it represent knowledge transfer from an earlier, more advanced civilization? The honest answer is that we don't know for certain. What we can say is that Göbekli Tepe and related sites have forced archaeologists to reconsider their assumptions about prehistoric peoples. The old narrative of steady, linear progress from primitive to civilized has been complicated. Hunter-gatherers were clearly capable of more than we gave them credit for. Whether that means they could have achieved what we see at Göbekli Tepe entirely on their own, or whether some form of knowledge transfer occurred, remains debated. Hancock's theory provides one possible explanation. Mainstream archaeology provides another. The evidence at this point doesn't definitively prove either interpretation wrong. What's clear is that something remarkable happened in southeastern Turkey around 11,000 to 12,000 years ago. A cultural fluorescence occurred. Monumental architecture appeared. Sophisticated, symbolic, and possibly astronomical knowledge was being expressed in stone. And this happened at precisely the time Hancock believes his Ice Age civilization was being destroyed elsewhere, its survivors scattering to teach what they knew to scattered hunter-gatherer populations. Is that timing coincidental, or is it evidence of cause and effect? That question takes us from Turkey to Egypt, to monuments even more famous than Göbekli Tepe, monuments that Hancock believes encode ancient knowledge in ways we're only beginning to understand: the pyramids and Sphinx of Giza. The 3 pyramids that stand on the Giza plateau outside Cairo are among the most famous structures on Earth. For thousands of years, they have inspired awe, speculation, and increasingly in recent centuries, careful scientific study. Standard Egyptology dates these pyramids to the Old Kingdom's 4th dynasty, around 2500 BC. The Great Pyramid is attributed to Pharaoh Khufu, the second pyramid to Khafre, and the third to Menkaure. Graham Hancock doesn't dispute that these pharaohs may have used or modified these structures. What he questions is whether they built them from scratch, and more fundamentally, whether the mathematical and astronomical knowledge encoded in their dimensions and positioning was available to Old Kingdom Egyptians, or whether it represents far older knowledge preserved from his proposed Ice Age civilization. Let's start with the Great Pyramid itself, because the precision of its construction is genuinely remarkable. The base of the pyramid is a square with sides originally measuring approximately 755 feet. The error in making this a perfect square is less than 2 inches. The sides are aligned almost perfectly to true north, south, east, and west, deviating by less than 1/60th of a degree, creating a structure with a 13-acre footprint. And achieving that level of precision would be challenging today with modern surveying equipment. How the ancient Egyptians achieved it with the tools we know they possessed remains a subject of debate. That they did achieve it is undeniable. the pyramid still stands as testimony. The Great Pyramid originally stood 481 feet tall. The angle of its faces is approximately 51.84 degrees. And here's where things get interesting mathematically. If you take the base perimeter of the pyramid and divide it by twice the height, you get a number extremely close to pi, 3.14159. The pyramid's dimensions encode the ratio of a circle's circumference to its diameter. Now, this could be coincidental. If you build a pyramid with a certain slope and measure it carefully enough, you might accidentally encode pi. But Hancock and other researchers point out that the pyramid also appears to encode the golden ratio phi, approximately 1.618, another fundamental mathematical constant. The ratio of the pyramid's slant height to half its base is close to phi. More dramatically, the Great Pyramid appears to be a scaled model of the northern hemisphere of Earth. Take the pyramid's height and multiply it by 43,200, and you get very close to Earth's polar radius. Take the base perimeter and multiply it by 43,200, and you get very close to Earth's equatorial circumference. Why 43,200? That number appears repeatedly in ancient mythology and sacred texts from around the world. It's a precessional number, derived from the astronomical phenomenon of the precession of the equinoxes. 1 degree of precession takes 72 years. Multiply that by 600, and you get 43,200. It's exactly half of the approximately 25,920 years it takes for the precession to complete a full cycle. Mainstream Egyptologists acknowledge these mathematical relationships but generally consider them coincidental, or argue that ancient Egyptians might have discovered some of these ratios empirically without understanding their full mathematical significance. They point out that pi and phi are not found in any Egyptian mathematical papyri that have survived. Yet the precision remains difficult to explain away entirely. The Great Pyramid wasn't built quickly or carelessly. Its construction would have required years, perhaps decades, of work by thousands of laborers. The precision in its orientation and dimensions wasn't accidental. Someone designed it very carefully. The question is whether that careful design intentionally encoded these mathematical relationships, or whether they emerged as byproducts of using certain proportions that the builders found aesthetically pleasing or structurally sound. Consider the practical challenges involved. To orient the pyramid so precisely to true north requires sophisticated astronomical observations. One method would be to observe the stars circling the north celestial pole and use geometrical techniques to find the pole's position precisely. Another would be to observe the sun's shadow at different times and use that to establish a true north-south line. Both methods require patience, precision, and mathematical knowledge. To create a base that's a near-perfect square over 13 acres requires equally impressive surveying techniques. Every corner had to be a precise right angle. Every side had to be the same length. The ground had to be leveled to an extremely flat surface, despite the natural bedrock having irregularities. Modern engineers marvel at this achievement even with our laser levels and theodolites. The construction itself presents puzzles that haven't been entirely solved. How were the massive limestone blocks, each weighing several tons, transported from nearby quarries, then lifted and positioned with such precision that you can't fit a blade between them? How were the even more massive granite blocks, weighing up to 70 tons each, transported from Aswan 500 miles away, then lifted hundreds of feet to be installed in the King's Chamber and the Grand Gallery? Various theories have been proposed. Ramps of different designs, external ramps that spiraled around the pyramid or internal ramps built within the structure itself. Counterweight systems, methods involving water or sand to float or lubricate the blocks. No single theory has been definitively proven, which leaves room for speculation, including Hancock's suggestion that the builders possessed knowledge or techniques we haven't rediscovered. Hancock argues that his proposed civilization might have achieved stoneworking mastery through generations or even thousands of years of development, knowledge that was then largely lost when their civilization was destroyed. This would explain why the earliest Egyptian pyramids show the highest levels of precision, with later pyramids being somewhat cruder, as if the knowledge was degrading rather than progressing. The interior of the Great Pyramid adds more puzzles. The so-called King's Chamber contains a granite coffer, usually interpreted as a sarcophagus, though no mummy has ever been found in it. The chamber itself is built with enormous granite blocks, some weighing 50 to 70 tons, transported from quarries 500 miles away at Aswan. The dimensions of the king's chamber encode more mathematical relationships. The chamber measures approximately 34.4 feet long, 17.2 feet wide, and 19.1 feet high. The ratios between these dimensions produce numbers that appear in various mathematical and geometrical relationships. The volume of the chamber in cubic feet yields numbers that some researchers connect to the length of the solar year and other astronomical periods, though these connections remain debated. The Grand Gallery leading to the King's Chamber is an architectural marvel, 153 feet long and 28 feet high, with precisely corbelled walls. The so-called Queen's Chamber has mysterious shafts that run at specific angles, not exiting the pyramid but stopping at what appear to be doors with metal handles. These shafts have been shown by researcher Robert Bauval to align with specific stars as they would have appeared around 2500 BC. The northern shaft from the King's Chamber points to where the star Thuban, then the Pole Star, would have been. The southern shaft points to where Orion's belt would have been at its meridian crossing. This astronomical alignment suggests that the pyramid's builders had sophisticated knowledge of the stars and deliberately encoded that knowledge in the monument's design. But why? If the pyramid was merely a tomb for Pharaoh Khufu, why all this astronomical sophistication? Why the mathematical precision? Why encode knowledge about the Earth's dimensions? Standard Egyptology struggles to provide satisfying answers to these questions, often falling back on vague references to symbolic or religious significance without fully explaining what that significance was or how it related to the specific numbers and alignments we observe. Hancock argues that the precision is too great to be accidental, and that the appearance of precessional numbers suggests knowledge of long-term astronomical cycles. He sees the Great Pyramid as a monument designed to encode important knowledge, a message in mathematics for future generations. This brings us to one of Hancock's most controversial claims, developed in collaboration with Robert Bauval, the Orion Correlation Theory. This theory proposes that the three Giza pyramids are laid out on the ground in a pattern that matches the three stars of Orion's belt as they appeared in the sky thousands of years ago. Look at the three pyramids from above. Two of them, Khufu's and Khafre's, are almost perfectly aligned along a southwest diagonal. The third, Menkare's, is slightly offset to the east of that line. Now look at Orion's belt. Two of its stars, Al-Nitak and Al-Nilam, form a straight line, while the third, Mintaka, is slightly offset. The pattern matches. Moreover, the Nile River runs alongside the Giza Plateau in roughly the same orientation as the Milky Way runs beside Orion in the sky. And nearby stands the Great Sphinx, a lion-bodied monument facing due east toward the sunrise. Bauval and Hancock propose that this ground plan represents the sky as it appeared at a specific moment, a moment they calculate using the phenomenon of precession. The precession of the equinoxes causes the stars to appear to drift slowly around the celestial sphere over a cycle of approximately 25,920 years. This means that Orion's belt would have appeared at different positions in the sky at different epochs in history. Using astronomical software to calculate backwards, Bauval and Hancock identified a specific moment when the correlation between the pyramids and Orion's belt, and between the Sphinx and the constellation of Leo, would have been perfect. That moment was around 10,500 BC, or approximately 12,500 years ago. This date is crucial for Hancock because it falls right around the time he believes his Ice Age civilization existed and was destroyed. The implication is that the Giza complex wasn't built in 2500 BC but rather marks a much earlier date, perhaps the date when the civilization existed, or perhaps a date the builders wanted to memorialize. The mainstream response to the Orion Correlation Theory has been largely critical. Astronomers Ed Krupp and Tony Farrell independently investigated the correlation and found that the angle between the pyramids doesn't match the angle between the stars as precisely as Bauval and Hancock claimed. The difference is several degrees, more than can be explained away. Critics also point out that the correspondence requires viewing one set of images, either the pyramids or the stars, upside down. The pyramids have their slight offset to the east, while Orion's belt has its offset in the opposite direction. To make them match, you have to flip one of them. Furthermore, the constellation of Leo, which the Sphinx supposedly represents, lies on the opposite side of the Milky Way from Orion. If the Nile represents the Milky Way, and the pyramids represent Orion, then the Sphinx representing Leo should be on the other side of the Nile. It isn't. Hancock and Barval have responded to these criticisms, arguing that some of the measurements have been selectively chosen by critics to make the correlation look worse than it is, and that the symbolic representation doesn't have to be geographically perfect to be meaningful. The debate continues, but there's another aspect to the Giza complex that doesn't rely on the Orion correlation. The Sphinx itself presents an age puzzle. The monument is carved from the limestone bedrock of the Giza plateau, with blocks removed from around its body to create a trench. Standard Egyptology attributes the Sphinx to Pharaoh Khafre around 2500 BC, based primarily on its proximity to Khafre's pyramid and some indirect evidence. However, geologist Robert Schoch has argued that the erosion patterns on the Sphinx and the walls of the trench around it are consistent with thousands of years of rainfall, not the wind erosion you'd expect in Egypt's desert climate over the past few thousand years. Egypt hasn't had that level of consistent rainfall since the end of the last ice age, around 10,000 to 12,000 years ago. If Schoch is right, and the debate remains contentious, it would mean the Sphinx is far older than 2500 BC. It might date back to a time when the climate in Egypt was much wetter at the end of the Ice Age. This would align with Hancock's timeline of an older civilization operating in this period. Mainstream geologists and Egyptologists have challenged Schoch's interpretation, offering alternative explanations for the erosion patterns. They point out that different parts of the Giza limestone weather differently, that water percolating through the rock can cause erosion patterns similar to what Schoch observed, and that the dating based on archaeology remains more reliable than interpretation of erosion patterns. Yet the debate refuses to die, in part because the erosion pattern question is joined by other anomalies. Why is there virtually no inscription or text in the Great Pyramid that definitively connects it to Khufu? The only evidence is a cartouche found in the so-called relieving chambers above the king's chamber, and even that has been questioned as potentially being a later addition or a forgery by the explorer who found it. Why would Khufu, if he built the largest pyramid on Earth, not plaster his name all over it as later pharaohs did with their monuments? Why is the Great Pyramid so geometrically and astronomically sophisticated compared to later pyramids, suggesting that knowledge was being lost rather than gained over time? These questions don't prove Hancock's theory correct, but they do suggest that the orthodox narrative may be incomplete. The Giza monuments remain mysterious in ways that standard Egyptology hasn't entirely resolved. Whether they encode knowledge from an Ice Age civilization, or whether they represent the peak achievement of Old Kingdom Egyptian architects working with knowledge developed over generations, or whether the truth is some combination of these possibilities, the pyramids and Sphinx continue to fascinate and challenge us. They stand as monuments to human capability, ingenuity, and perhaps to mysteries we have yet to fully understand. Among the more intriguing evidence Graham Hancock presents for his lost Ice Age civilization is a collection of ancient maps. These maps, most of them created in the medieval and Renaissance periods, appear to contain geographical information that shouldn't have been available to the cartographers who drew them. Some show coastlines with a level of accuracy that wasn't achieved by European mapmakers until much later. Others appear to depict land masses in configurations that only existed during the Ice Age, when sea levels were hundreds of feet lower than today. The most famous of these maps is the Piri Reis map of 1513. Piri Reis was an Ottoman admiral and cartographer. The map that bears his name is actually a fragment, showing part of the western coast of Africa and the eastern coast of South America, with notations indicating it was compiled from approximately 20 older source maps, including maps used by Christopher Columbus. What makes this map remarkable is that it appears to show the coast of South America with reasonable accuracy, even though European contact with that continent was very recent in 1513. More controversially, the map shows what some interpreters, including Hancock, believe is the coast of Antarctica continuing below the South American tip. If that interpretation is correct, it's highly anomalous because Antarctica wasn't officially discovered until 1820, more than 300 years after the Piri Reis map was drawn. Even more puzzling, the coastline shown, if it is Antarctica, appears to match not the ice-covered coast we know today, but the actual rocky coastline beneath the ice, which wasn't mapped until the 1952 using seismic sounding equipment. Charles Hapgood, a professor of history who studied these maps extensively in the 1960 seconds, argued that they contain information that could only have been obtained by a civilization capable of global seafaring and sophisticated map-making techniques, possibly during the Ice Age when some of Antarctica's coast may have been ice-free. The Piri-Reis map is not alone. The Orontius Phineas map of 1531 shows what appears to be the entire continent of Antarctica, depicted with reasonable accuracy for its overall shape, at a time when Europeans supposedly didn't know the continent existed. The Mercator map of 1569 similarly shows Antarctic features. Hancock argues that these maps are copies of copies, drawn from source maps that go back much further than the medieval period. Each copying would introduce errors and distortions, but core information, particularly about coastlines and latitudes, could be preserved. The original source maps, he proposes, were drawn by his Ice Age civilization, which had the technology to accurately survey the world. Critics of this interpretation point out several problems. First, the maps aren't as accurate as proponents claim. When examined carefully, they contain numerous errors and distortions. Coastlines that seem to match modern geography only do so if you squint and are generous in your interpretation. Second, the supposed Antarctic coastline on the Piri-Reis map could be a distorted representation of South American coastline, not Antarctica at all. Medieval and Renaissance maps are full of speculative geography, lands drawn in because cartographers assumed they must be there, not because anyone had actually surveyed them. Third, the latitudes and longitudes on these maps, when they exist at all, are often wildly inaccurate. Determining longitude, in particular, requires precise timekeeping, which wasn't available until the invention of the marine chronometer in the 18th century. How could Ice Age civilizations have achieved this? Hancock's response is that we're judging these ancient maps by modern standards and missing the remarkable information they do contain. He notes that even mainstream scholars acknowledge these maps drew on older sources, and that some of them contain information that's puzzling given what we know about the knowledge available at the time they were drawn. There's also the question of how certain features of geography appear on maps before they were supposedly discovered. The map of Race shows islands in the Caribbean that were unknown to Europeans in 1513. Portolan charts, navigational maps from the 13th to 15th centuries, show coastlines of the Mediterranean and Black Sea with remarkable accuracy, including harbors and coastal features. Mainstream historians explain these maps as the product of extensive practical seafaring knowledge accumulated over generations. Sailors would have known these coastlines intimately from experience, and that knowledge was compiled into maps. Fair enough. But some of the maps show regions that weren't being regularly sailed by the cultures that produced the maps. How did that information get transferred? Hancock weaves these maps into his larger narrative about a lost seafaring civilization. If his Ice Age civilization existed and had global reach, they would have needed to map the world. Those maps would have been precious documents. If some survived the cataclysm, or if the knowledge they contained was passed down through generations, they could have influenced later cartography in ways we don't fully understand. He also points to another curious feature of some ancient maps. Several of them are drawn using projections that suggest understanding of the Earth as a sphere, and sophisticated mathematical techniques for representing that sphere on a flat surface. The Piri-Reis map, for instance, appears to use an azimuthal equidistant projection centered on Cairo. This is a modern projection type that requires considerable mathematical knowledge to construct. Could medieval cartographers have had this knowledge? Possibly. Islamic scholars, in particular, preserved and advanced geographical and mathematical knowledge during the medieval period. But the question remains, where did that knowledge ultimately come from? The ancient maps are perhaps the most circumstantial of Hancock's evidence. They don't prove a lost civilization existed. They're open to multiple interpretations, and many mainstream scholars aren't convinced they show anything anomalous once you account for errors, distortions, and the speculative nature of early cartography. Yet they remain tantalizing. If even a few of these maps do contain information that predates the civilizations that drew them, it suggests someone, somewhere, had that knowledge earlier. Whether that someone was Hancock's Ice Age civilization, or whether the knowledge was preserved through more conventional means from earlier cultures we do know about, remains an open question. What we can say is that the history of cartography is more complex than a simple linear progression from crude to accurate. Knowledge was gained and lost, preserved and forgotten, transmitted across cultures in ways we don't always fully understand. These ancient maps hint at that complex history, even if they don't definitively prove the existence of Atlantis. One of Graham Hancock's most persistent arguments for a lost Ice Age civilization rests not on physical artifacts or monuments, but on patterns he identifies in the myths, legends, and religious beliefs of cultures separated by vast distances and thousands of years. If these widely separated cultures share specific stories, symbols, or knowledge, he argues, it's more plausible that they inherited them from a common source than that they independently invented the same ideas. This argument takes various forms. There's the prevalence of flood myths, which Hancock interprets as memories of the catastrophic flooding at the end of the Ice Age. There's the recurring motif of civilizing heroes or gods who arrive from across the sea or down from the sky to teach humanity agriculture, writing, astronomy, and ethics. There's the appearance of similar architectural styles and astronomical knowledge in cultures that supposedly had no contact. Let's examine these claimed connections carefully, because they're both the most evocative and the most disputed aspects of Hancock's work. Flood myths are indeed ubiquitous. The story of Noah is familiar from the Bible, but it's actually borrowed from much older Mesopotamian sources, particularly the Epic of Gilgamesh, which describes Utnapishtim surviving a great deluge sent by the gods. Ancient Greek tradition tells of Deucalion and Pyrrha surviving a flood sent by Zeus. Hindu texts describe Manu being saved from a flood by the god Vishnu in the form of a fish. Mayan texts speak of previous world ages destroyed by floods. Native American traditions across various tribes contain flood stories. Aboriginal Australian traditions describe rising sea levels swallowing the land. Chinese mythology includes flood narratives. The list goes on. Hancock interprets this global distribution of flood myths as evidence that humanity experienced a common catastrophe. The Younger Dryas flooding, he believes, resulted from comet impacts and rapid ice sheet melting. The survivors, he suggests, passed down the memory of this event, which was then preserved in the mythological traditions of their descendants. Mainstream anthropologists and folklorists offer a different explanation. They note that floods are common natural disasters that affect human communities in many parts of the world. Rivers overflow their banks. Coastal areas are inundated by tsunamis. When such events occur, they're traumatic enough to be preserved in oral tradition. Over time, these stories can be embellished, taking on cosmic significance as divine punishment or world-ending cataclysms. The fact that many cultures have flood myths, according to this mainstream view, doesn't require a single global flood. It merely requires that flooding is a common human experience. The similarities in the stories, a righteous man warned by the gods, the building of a boat, the saving of animals, the rebirth of humanity, these can be explained by the narrative logic of disaster stories and the human tendency to frame traumatic events in archetypal terms. Who's right? Both explanations have merit. The end of the Ice Age did involve massive flooding as sea levels rose by about 400 feet over several thousand years. This wasn't a single event, but a series of rises, some gradual, some possibly quite rapid when ice dams holding back glacial lakes failed. Coastlines that had been inhabited for generations were submerged. For people living through these events, it would have seemed like the world was drowning. But does that prove the flood myths derive from a single globally unified event passed down from an Ice Age civilization? Not necessarily. It could mean that different populations experienced similar flooding events at different times and places as the Ice Age ended, and independently developed similar narratives to explain those events. The recurring figure of the civilizing hero presents similar interpretive challenges. In Egyptian tradition, it's Osiris and Thoth who bring knowledge to humanity after the primordial time called Zep Tepi. In Sumerian tradition, it's the Apkallu, wise beings who emerge from the sea to teach civilization. In Mesoamerican cultures, it's Quetzalcoatl, the feathered serpent, often depicted as arriving from across the ocean. In South America, it's Viracocha. In India, various avatars of the gods play this role. Hancock sees these figures as mythologized memories of real people, survivors of his Ice Age civilization who brought their knowledge to scattered hunter-gatherer populations after the Younger Dryas catastrophe. Each culture remembered these teachers, and elevated them to divine status over the generations. Critics respond that the civilizing hero is a nearly universal mythological archetype. Cultures everywhere tell origin stories explaining how they acquired essential knowledge and skills. Attributing this knowledge to gods or culture heroes is a natural way to express its importance and legitimize cultural practices. You don't need a historical lost civilization to explain why different cultures independently developed similar mythological motifs. Then there's the question of shared symbols and knowledge. Hancock and others have pointed to the appearance of certain symbols across widely separated cultures. The swastika, for instance, appears in Hindu tradition, in Native American art, in Celtic design, in ancient Mesopotamia. The pyramid form appears in Egypt, Mesoamerica, and Southeast Asia. Serpent symbolism is found in virtually every ancient culture. Do these shared symbols indicate a common origin, or are they examples of what psychologists call convergent symbolism? The human mind independently arriving at similar solutions to expressing similar concepts. The swastika is a simple geometric form that can easily arise independently. The pyramid is a stable structure that ancient builders might naturally discover when trying to build tall monuments. Serpents are common animals that would be significant in many cultures. More intriguing are claims of shared astronomical knowledge. Hancock emphasizes that various ancient cultures appear to have understood the precession of the equinoxes, a phenomenon that takes nearly 26,000 years to complete. They encoded this knowledge in their myths using specific numbers that relate to precession. 7. 2. The number of years for 1 degree of precession. 2,160. The length of one astrological age. 25,920. The full precessional cycle, and various multiples and divisions of these numbers. The numbers appear in unexpected places. The Norse Eddas speak of 540 doors in Valhalla, with 800 warriors emerging from each, for a total of 432,000. That's 43,200 times 10, one of those key precessional numbers. Hindu cosmology describes time cycles involving similar numbers. Egyptian texts contain numerical references that can be linked to precession. These numerical coincidences, if they are coincidences, appear with surprising frequency across cultures that supposedly had no contact. In Hamlet's Mill, a scholarly work by Giorgio de Santillana and Hertha von de Chend, the authors document these precessional numbers appearing in myths from around the world, from Polynesia to Iceland, from India to Mesoamerica. They argue that these numbers represent an ancient, sophisticated understanding of astronomical cycles that was encoded in mythology as a way of preserving the knowledge across generations and catastrophes. Let's consider specific examples. The Mayan long count calendar, which gained fame before the year 2012, operates on cycles that some researchers link to precessional periods. While the mainstream interpretation sees the long count as primarily concerned with historical timekeeping and the legitimization of Mayan rulers through connection to mythic creation dates, alternative researchers, including Hancock, note that some of the numbers involved in Mayan timekeeping connect to precessional cycles. In ancient Mesopotamia, the Sumerian king list records the reigns of kings before the flood, with reign lengths often given in terms of thousands of years, numbers that strain credulity if taken literally, but that might represent something else. Perhaps astronomical cycles, perhaps spans of cultural epochs, encoded in the form of king lists. The ancient Greek tradition preserved by Plato places Atlantis' destruction 9,000 years before his time, which would be approximately 9,600 BC, or roughly 11,600 years ago. That date falls right into the period Hancock identifies as crucial. The end of the Younger Dryas, the time when catastrophic climate change and flooding were occurring. Could Plato's date preserve a genuine memory of when the catastrophe occurred, even if his description of Atlantis itself is embroidered with later Greek mythological and philosophical elements? In ancient Egypt, the concept of Zep Tepi, the first time, refers to a primordial epoch when the gods established order out of chaos, when the foundations of Egyptian civilization were laid. The Egyptians themselves traced their origins back to this mythic time, maintaining that their knowledge of astronomy, architecture, medicine, and ethics ultimately derived from teachings given by the gods during Zep Tepi. Later, pharaohs presented themselves as maintaining and renewing the order established in that first time, not as innovators creating something new, Similar concepts appear in other ancient cultures. The Hindu yugas describe vast cycles of time, with the current age being one of decline from earlier, more perfect ages. The ancient Chinese historical tradition speaks of sage rulers in remote antiquity who established civilization. Mesoamerican cultures described previous world ages that had been destroyed, with each new age beginning after catastrophe. Are these myths evidence of real events, memories of a time when civilization did exist at a higher level before being destroyed and having to rebuild? Or are they expressions of a universal human tendency to imagine a perfect past, a golden age from which we have fallen, whether or not such a past ever existed? Psychologically, the myth of the golden age appears across cultures. It may reflect nostalgia, the tendency to remember the past more favorably than it actually was. It may express a psychological archetype, a story structure that resonates with the human mind regardless of historical accuracy. Or it may, as Hancock suggests, preserve genuine historical memory, distorted and mythologized, but retaining a core of truth about a time when an advanced civilization existed and was destroyed. Then there's the architectural question. Pyramid structures appear in Egypt, Mesoamerica, and Southeast Asia. They're often cited as evidence of a common origin or shared knowledge. The reasoning is that the pyramid is such a specific form. Why would cultures separated by oceans and thousands of miles independently choose to build pyramids? Critics respond that the pyramid is actually a quite natural form to discover when you want to build a tall structure with available technology. It's stable. The base can be as large as you want, providing plenty of stone-bearing capacity, while the structure tapers as it rises, reducing weight higher up. A pyramid won't fall over like a tall, thin tower might. It's essentially a pile of stones arranged in the most stable configuration possible. Moreover, when you look closely at pyramids from different cultures, they're actually quite different in form, function, and construction method. Egyptian pyramids are smooth-sided, built with carefully cut and fitted stones, serving primarily as tombs and monuments. Mesoamerican pyramids are step pyramids, built with rubble cores and stone facing, topped with temples where rituals were performed. They served fundamentally different functions and were built using different techniques, yet the similarity in form is striking enough that it requires explanation. Independent invention of a basic geometric form is plausible, but Hancock pushes further, pointing to specific similarities that he argues go beyond the basic pyramid shape. He notes that both Egyptian and Mesoamerican pyramids were often astronomically aligned. Both cultures showed sophisticated knowledge of mathematics and astronomy. Both had complex religious systems centered on death and rebirth. Both practiced mummification. These are no longer about the pyramid form itself, but about cultural practices and knowledge systems. Do they suggest contact or common origin? Or do they reflect universal human concerns about death, about the cosmos, about the relationship between humans and the divine, which led different cultures to develop similar responses independently? The debate over these connections often reaches no definitive conclusion because we're dealing with questions that the available evidence doesn't decisively answer. Was there transoceanic contact between ancient civilizations before we think there was? Possibly. Some evidence, like the presence of cocaine in Egyptian mummies or the appearance of what look like African features in Olmec heads, has been cited as supporting contact. But each piece of evidence has been disputed or explained alternatively. Was there a common Ice Age source civilization that taught multiple later cultures? Hancock thinks so. Mainstream archaeology says the evidence isn't there. Independent development, they argue, can explain the similarities without requiring a lost civilization. The human mind is creative but also limited. Faced with similar challenges and possessed of similar cognitive capacities, different cultures will sometimes arrive at similar solutions. That's convergent evolution, not diffusion from a common source. What's clear is that ancient peoples were far more capable, sophisticated, and interconnected than we often give them credit for. They were skilled observers of nature, patient astronomers who tracked celestial cycles across generations, ingenious engineers who solved construction problems with available materials, and creative thinkers who developed rich philosophical and religious systems to make sense of their existence. Whether they learned from an earlier, more advanced civilization or developed their capabilities through their own ingenuity and the accumulation of knowledge across generations is the key question. Hancock's work emphasizes the former possibility. Mainstream archaeology emphasizes the latter. The truth may involve elements of both, cultures developing locally but also exchanging ideas and knowledge across greater distances and time spans than we often recognize. What we can say with confidence is that the patterns Hancock identifies are real and worth investigating. Ancient cultures did encode sophisticated knowledge in their monuments and myths. They did share certain symbols, numbers, and narratives across vast distances. Understanding how this happened, whether through common origins, through diffusion and contact, through psychological universals, or through some combination of these mechanisms, remains an active and important area of inquiry. Hancock argues that this sophisticated astronomical knowledge, appearing in cultures separated by vast distances, must have come from a common source, his Ice Age civilization. Mainstream scholars suggest that some of these numerical coincidences are just that, coincidences, while others might represent independent astronomical observations by cultures that closely watched the sky over many generations. Who's right? The answer may be more nuanced than either side admits. It's clear that many ancient cultures were skilled astronomers who carefully observed celestial phenomena. Some of them certainly understood long-term astronomical cycles. Whether they learned this independently or whether there was some transmission of knowledge between cultures remains debated. What we can say is that Hancock has identified real patterns, real similarities in myths, symbols, and knowledge across ancient cultures. Where he goes beyond what the evidence can clearly support is in attributing all these patterns to a single lost civilization. Alternative explanations, independent development, cultural diffusion through trade and migration, universal human psychological tendencies, can account for many of the similarities without requiring an Atlantean source. But the patterns are real and worth investigating. Whether they ultimately support Hancock's grand narrative or a more conventional understanding of cultural development and exchange, they remind us that our ancestors were sophisticated observers of their world who encoded profound knowledge in their myths and monuments. Understanding how that knowledge arose and spread remains an active area of research, and the debate between Hancock's interpretation and mainstream archaeological views continues to drive new questions and investigations. Graham Hancock is no stranger to criticism. For decades, mainstream archaeologists, historians, and scientists have challenged his work, often in terms that go beyond mere academic disagreement into what seems like personal animosity. Understanding why requires examining both what academics see as flaws in Hancock's methodology and the larger context of how his work affects the public perception of archaeology. The criticism of Hancock's work is multifaceted, but several key themes recur. Let's examine them objectively, because they help us understand the fundamental disagreement between alternative archaeology and the mainstream discipline. First, there's the issue of evidence standards. Archaeology is a scientific discipline that builds its understanding through systematic excavation, careful dating of materials, analysis of artifacts in their context, and rigorous peer review of findings. Archaeologists are trained to be conservative in their interpretations, to avoid making claims that go beyond what the physical evidence can support. Hancock's approach is different. He synthesizes information from multiple disciplines: archaeology, geology, mythology, archaeoastronomy, and looks for patterns that suggest connections mainstream scholars miss. This isn't inherently problematic. Interdisciplinary work can yield valuable insights. But critics argue that Hancock cherry-picks evidence, emphasizing findings that support his theory while ignoring or downplaying contrary evidence. For example, when discussing Göbekli Tepe, Hancock emphasizes its sophistication and early date. He notes the massive stones, the intricate carvings, the apparent astronomical alignments. What he gives less attention to, critics say, is the archaeological context showing gradual development in the region before Göbekli Tepe, the absence of writing or metallurgy at the site, and the mainstream interpretation that attributes it to capable hunter-gatherers rather than a lost civilization. Second, there's the argument from ignorance. This is when someone claims that because we can't explain something within current paradigms, an alternative explanation must be true. Hancock frequently points to unsolved mysteries or debates in archaeology: the dating of the Sphinx, the purpose of certain structures, the source of certain types of knowledge, and argues that his lost civilization theory explains them better than conventional archaeology does. Critics respond that just because we don't yet have complete answers to every question doesn't mean we should abandon well-supported frameworks. Science progresses by filling in gaps in knowledge, not by overturning entire paradigms every time we encounter something puzzling. Moreover, many of the mysteries Hancock emphasizes are less mysterious than he suggests once you examine the full body of research rather than focusing only on the anomalous aspects. Third, there's concern about what academics call hyper-diffusionism, the idea that civilizational advances spread from a single source rather than arising independently in different places. Hancock's theory is that an Ice Age civilization was the ultimate source of agricultural, architectural, and astronomical knowledge that appears in various ancient civilizations. This knowledge was brought by survivors of the Catastrophe who traveled the world as missionaries of civilization. Archaeologists see this as problematic for several reasons. It diminishes the achievements of the cultures we know existed, suggesting they couldn't have developed these capabilities on their own but needed instruction from a superior lost civilization. It oversimplifies the complex, varied, and locally adapted nature of how different civilizations actually developed. And it echoes older, discredited theories that were sometimes used to support colonialist and racist ideologies. This last point deserves emphasis because it's where the criticism of Hancock becomes most heated. In the 19th and early 20th centuries, some European scholars promoted ideas of lost white civilizations to explain the achievements of non-European cultures. The monuments of ancient Egypt, the cities of Mesoamerica, these were sometimes attributed to vanished white races or even extraterrestrials rather than to the ancestors of the people living in those regions. Hancock has repeatedly stated that this is not his position. He doesn't specify the race of his proposed Ice Age civilization, and he's explicitly rejected racist interpretations of his work. Nevertheless, academic critics argue that his underlying logic, ancient peoples couldn't have achieved what we see without outside help, parallels those older racist theories, even if his intentions are different. This concern escalated with Hancock's Netflix series Ancient Apocalypse, which attracted enormous viewership and brought his ideas to a massive global audience. The Society for American Archaeology issued an open letter to Netflix, asking them to reclassify the show as science fiction rather than documentary. They argued that it promoted pseudoscience, villainized archaeologists, and echoed colonial-era ideologies. Hancock responded forcefully, arguing that he was being unfairly censored by an archaeological establishment that couldn't tolerate challenges to its orthodoxy. The debate became increasingly polarized, with accusations flying in both directions. From the mainstream archaeological perspective, the frustration stems partly from the asymmetry of attention. Archaeologists spend years carefully excavating sites, analyzing data, publishing findings in peer-reviewed journals that few non-specialists read. Hancock writes best-selling books and stars in popular documentaries seen by millions. His dramatic narratives of lost civilizations and ancient mysteries are more engaging to the public than careful archaeological papers discussing pottery typologies and stratigraphic analysis. When members of the public then come to archaeological sites or museums with expectations shaped by Hancock's work, expecting evidence of advanced Ice Age civilizations or ancient aliens, archaeologists feel their actual work is being overshadowed and undermined by what they see as entertaining but misleading speculation. There's also a genuine intellectual disagreement about how to interpret ambiguous evidence. Take the precession of the equinoxes. Hancock argues that ancient cultures knew about this phenomenon and encoded it in their monuments and myths. Mainstream Egyptologists generally believe the ancient Egyptians didn't understand precession, that it wasn't discovered until Hipparchus in the 2nd century BC. Who's right? The evidence isn't conclusive either way. The Egyptian temple alignments that Hancock and Robert Bauval cite as evidence of precessional knowledge can be interpreted differently. The numerical patterns in myths could be coincidental or have different meanings than precessional encoding. This is a legitimate scholarly disagreement where reasonable people examining the same evidence reach different conclusions. The problem is that this disagreement has become so politicized and personal that productive dialogue is difficult. Hancock sees archaeologists as narrow-minded gatekeepers protecting their turf. Archaeologists see Hancock as a popularizer who lacks the training and rigor to make the claims he makes. Both sides sometimes caricature the other rather than engaging seriously with the strongest versions of each other's arguments. Is there a middle ground? Perhaps. Some archaeologists, while rejecting Hancock's overarching theory of a lost Ice Age civilization, acknowledge that he's raised interesting questions about certain sites and time periods. The end of the Ice Age was a time of dramatic change, with rising sea levels, megafauna extinctions, climate shifts, and the eventual emergence of complex societies. Understanding this transition fully remains an active area of research. The Younger Dryas impact hypothesis, which is central to Hancock's catastrophe narrative, began as a fringe idea but has gained some scientific traction, even though it remains controversial. Göbekli Tepe and related sites have indeed challenged previous assumptions about hunter-gatherer capabilities. The erosion patterns on the Sphinx continue to generate debate, even among mainstream geologists. What remains clear is that extraordinary claims require extraordinary evidence. Hancock's claim of an advanced Ice Age civilization that mapped the world, understood precession, and built monuments encoding this knowledge is certainly extraordinary. Whether the evidence he presents rises to the level necessary to support such a claim is where the fundamental disagreement lies. Mainstream archaeologists argue it doesn't. They point out that for all Hancock's documentation of intriguing anomalies and unexplained features, he hasn't produced the kind of unambiguous evidence that would be expected from an advanced civilization. Cities, clear technological artifacts, undisputed writing systems, widespread material culture that can be dated to the Ice Age period. Hancock responds that the catastrophic nature of the civilization's destruction, combined with the submergence of coastal areas where they would have lived, explains the lack of obvious evidence. He argues that mainstream archaeology isn't looking in the right places or asking the right questions, and that new discoveries continue to push back the dates of human sophistication in ways that support aspects of his theory. The debate seems unlikely to be resolved soon. What we can hope for is that it remains productive, rather than devolving into pure tribalism. When either side stops genuinely engaging with evidence and arguments, and merely attacks the other side's motives or character, we all lose. The past is genuinely mysterious in many ways, and understanding it requires both rigorous scientific standards and willingness to question assumptions when new evidence emerges. Finding the balance between skepticism and openness is the challenge for everyone interested in human origins and ancient history. As our journey through Graham Hancock's theories draws to a close, it's worth stepping back to consider what's actually at stake in this debate. This isn't merely an academic disagreement about archaeological interpretation. It's a fundamental question about how we understand human history, human capability, and ultimately, ourselves. If Hancock is right, if an advanced civilization did exist during the Ice Age and was largely destroyed around 12,000 years ago, the implications would be profound. Our entire timeline of human development would need to be rewritten. The story we tell ourselves about the linear march from primitive to civilized would be revealed as incomplete or false. We would have to grapple with the humbling reality that an earlier version of human civilization achieved sophisticated knowledge that was then largely lost, only to be slowly rediscovered over thousands of years. This realization could change how we think about progress. We assume that human society inevitably advances, that knowledge accumulates and is passed down, that we're always building on the achievements of those who came before. But if a catastrophe could erase an advanced civilization so thoroughly that we're only now piecing together its existence, what does that mean for our own civilization's vulnerability? Hancock himself has emphasized this aspect of his work. He argues that one reason the hypothetical Ice Age civilization encoded astronomical knowledge in monuments was to warn future generations. They had experienced a cosmic catastrophe and wanted to ensure their descendants knew that such events could happen again. In this reading, places like Göbekli Tepe or the pyramids of Giza aren't just monuments to past glory but warnings about future danger. This ties into contemporary concerns about asteroid impacts, climate change, and civilizational fragility. We live in an interconnected global civilization that has achieved remarkable technological sophistication. But we're also vulnerable in ways we don't fully appreciate. Our knowledge is increasingly digitized, dependent on infrastructure that could be disrupted. Our food systems are complex and interdependent. Our climate is changing in ways that could prove catastrophic. If something happened to our civilization, how much of our knowledge and achievements would survive for future generations to discover? These are genuine questions worth pondering, regardless of whether Hancock's specific historical claims are correct. But they also reveal something important about why his work resonates with so many people. In an age of increasing uncertainty, where established institutions seem unable to address major challenges, where official narratives are increasingly questioned, the idea that mainstream academics are missing or suppressing important truths about the past appeals to a growing sense that we're not being told the whole story about many things. Hancock positions himself as a challenger of orthodoxy, someone willing to ask uncomfortable questions and follow evidence wherever it leads, even when that puts him at odds with academic consensus. His supporters see him as intellectually brave. His critics see him as undermining genuine scientific inquiry by promoting theories that sound plausible to the public but don't withstand scholarly scrutiny. There's also a spiritual dimension to Hancock's work that shouldn't be overlooked. He's been explicit about his use of ayahuasca and his belief that psychedelic substances can provide access to knowledge and states of consciousness that materialist science dismisses. He suggested that his hypothetical Ice Age civilization possessed spiritual wisdom and techniques for altering consciousness that we've lost. This aspect of his work connects with broader cultural interests in alternative spirituality, consciousness exploration, and rejection of purely materialist worldviews. For many people, Hancock isn't just offering a different interpretation of archaeological data. He's suggesting that ancient peoples had wisdom about the nature of reality that modern science, in its focus on the purely physical, has missed or dismissed. Mainstream archaeologists generally avoid engaging with this spiritual dimension of Hancock's work. They focus on the empirical claims about monuments, dating, and evidence. But for many of Hancock's readers and viewers, the spiritual aspect is inseparable from the historical claims. The idea that ancient civilizations understood consciousness in deeper ways than we do, that they had spiritual technologies we've forgotten, this resonates with people seeking meaning beyond what mainstream science offers. So where does this leave us? After examining Hancock's evidence, the mainstream rebuttals, the areas of genuine uncertainty and ongoing research, what should we conclude? The honest answer is that absolute certainty in either direction isn't warranted by the evidence currently available. Hancock hasn't definitively proven his Ice Age civilization existed. The lack of unambiguous archaeological evidence for cities, writing, or technological artifacts from that period remains a serious problem for his theory. Many of the sites and claims he emphasizes can be explained within conventional archaeological frameworks without requiring a lost civilization. At the same time, mainstream archaeology hasn't entirely closed the door on the possibility that our understanding of human prehistory is incomplete. New discoveries continue to push back dates for human achievements. Göbekli Tepe and related sites were genuinely unexpected and have forced reconsideration of hunter-gatherer capabilities. The Younger Dryas impact hypothesis, while still disputed, has more scientific support than it did 15 years ago. There are legitimate mysteries about ancient monuments and astronomical knowledge that haven't been completely resolved. What we can say is that human history is more complex than any simple narrative, whether orthodox or alternative, can capture. Our ancestors were remarkably capable, achieving sophisticated architecture, astronomical knowledge, and cultural complexity far earlier than was previously believed. Whether they learned some of this from an even earlier civilization, or whether they developed it independently through the ingenuity and accumulated knowledge of generations, the achievements remain impressive. The debate between Hancock and mainstream archaeology, for all its heat and occasional rancor, has had some positive effects. It's brought attention to fascinating archaeological sites and periods of human history. It's encouraged people to think critically about how we know what we know about the past. It's raised questions that, even if not answered in the way Hancock suggests, are worth investigating further. For those drawn to Hancock's work, the appeal is clear. His theories are dramatic, romantic, and intellectually exciting. They suggest that history is full of hidden wonders and forgotten knowledge. They position ancient peoples as wise and sophisticated rather than primitive. They offer the tantalizing possibility that we might rediscover lost wisdom that could help us address contemporary challenges. For archaeologists and scholars, the frustration is equally understandable. They've dedicated their lives to careful, systematic study of the past. They've developed rigorous methods for extracting reliable knowledge from fragmentary evidence. When someone with significant public reach makes claims that seem to bypass or contradict this careful work, presenting speculation as revelation, it's natural to respond defensively. The path forward requires both sides to engage more generously with each other. Hancock and his supporters need to acknowledge the value of rigorous archaeological methodology and the genuine expertise mainstream scholars bring to their work. They need to recognize that not every mystery or anomaly requires upending the entire framework of how we understand the past. Mainstream archaeologists, for their part, need to acknowledge that public interest in the mysteries Hancock highlights reflects genuine curiosity about human origins and history. Rather than dismissing this interest as ignorance or gullibility, they should find better ways to communicate their own findings and to explore the legitimate questions Hancock raises, even if they reach different conclusions. The past is a foreign country. We can never know it with absolute certainty. We piece together fragments, material remains, texts, traditions, and construct narratives that make sense of them. These narratives are always provisional, always subject to revision as new evidence emerges or as we develop new ways of interpreting old evidence. Graham Hancock has constructed one such narrative, sweeping, dramatic, and deeply appealing to many. Mainstream archaeology has constructed another, more cautious, more firmly grounded in conventional evidence, but perhaps less emotionally resonant for the public. The truth, as it often does, may lie somewhere in the complex space between these poles. What matters most is that we keep asking questions, keep examining evidence, keep challenging assumptions, including our own, while maintaining intellectual honesty and rigor. The story of human civilization is too important to be treated as settled fact when genuine mysteries remain. But it's also too important to be rewritten based on speculation and selective interpretation of ambiguous evidence. Whether you find Hancock's theories compelling or problematic, engaging with them seriously requires the same combination of open-mindedness and critical thinking that any historical investigation demands. Don't accept claims uncritically from any source. Don't dismiss questions because they challenge orthodoxy. Examine evidence carefully. Consider alternative explanations. Follow where the evidence leads, not where you wish it would lead. The ancient world holds genuine mysteries. Understanding our past helps us understand ourselves. Whether that past includes a lost Ice Age civilization remains one of the great unsettled questions. Exploring it with both imagination and rigor is how we'll move closer to answers, whatever those answers turn out to be. Thank you for joining this exploration tonight. If you enjoyed this journey into controversial archaeology and ancient mysteries, please like and subscribe. There are countless other enigmas waiting to be examined, from ancient civilizations to lost knowledge, from unexplained monuments to forgotten histories. The past is never entirely past. It shapes who we are and hints at who we might become. Until next time, keep questioning, keep learning, and never stop wondering about the mysteries that surround us. Good night.